Okay, so this is action code E, reacting masses, and this is using the method that Mr Varty showed you in my absence last Friday. Okay, so this method is still based on the formula triangle, but it combines it all into one calculation. So if we take our formula triangle that we've seen before, but add a subtlety, okay, so there we go, there's a piece of paper. So let's call this the reactance triangle. Let's call this the product triangle. And as we've seen before, you've got your mass, you've got your MR, and you've got your moles, and then you've got mass, MR, and moles. And if we slightly rename these items, so if we call this the reacting mass divided by the reactant MR times by the reactant mole equals the product mass divided by the product MR times the product mole. I'll simply put these letters onto the various things to differentiate them. Now, usually in these sorts of questions, what we're asked to find is the product mass. Okay, so if we rearrange this equation in favour of the product mass, so we've got product mass is what we're after usually in these questions. So that would equal, and I'm just going to take all these items here and just rewrite them. So R mass, that's the reactant mass, divided by the reactant MR times by the reactant mole. And then to move these items onto the other side of the equation, we would need to multiply both sides of the equation by these. So that means we end up with PMR and P mole over here. Okay, so Mr Varty's method is based on this equation here, but often the two moles, if it's a one-to-one reaction, they cancel each other out anyway, so we don't need to worry about them. Okay, so if we bear that in mind for the calculations. Okay, so this is the calculation in the TIM task. So on here, we're told that copper is an important metal in everyday life. It can be produced from its oxide by heating with carbon. The equation of the reaction is shown below. Okay, so we've got 2 lots of copper, 1 lot of carbon, reacting with makes 2 coppers and 1 carbon dioxide. If we read on, it says use the equation to calculate the maximum mass of copper. Okay, so here's copper is a chemical of interest that could be produced when using 1.5 tons of carbon. Okay, so these are the 2 chemicals that we're interested in. We don't need to worry about that one. We don't need to worry about that one. Okay, so this here is the reactant, and this is the product. Okay, so if we take the equation that we just worked out, we're interested in the product mass. Okay, because the question asks for the maximum mass of copper. And as we saw a moment ago, then we can calculate that by taking the reactant mass, multiplying that by the product MR, multiplying that by the product moles, then divide all that by the reactant MR times by the reactant moles. So if we take from the question and our sort of other knowledge, the values we need to complete this equation. So the reactant mass, okay, is the mass of carbon, which is 1.5 tons. Okay, so we'll put in 1.5, multiply that by the product MR. So the product is copper, okay, and it's MR or AR in actual fact, because it's an element is 64. We'll times that by 64. Now here's where we need to be careful. We need the product moles, so we get that information from the equation. Okay, so that's at 2. It's 2 moles of copper. That's the product. And then we divide that by the reactant MR. So the reactant is carbon, and its MR is 12, or AR, but they are equivalent in this instance. And then the reactant moles, okay, so the reactant is carbon, and we've seen that there's only 1 mole of reactant required. So if we multiply that out and divide it by 12, because of course 12 times 1 is 12, then we will get 16 tons. Okay, so that's the all-in-one method, if you like. Okay, we move on to the final question. This action code. The overall reaction taking place is shown in the equation below. 2 sodium chlorides make 2 sodiums and 1 chlorine gas. Let's find out what we're actually interested in. So when we carry out this reaction, 120 kilograms of sodium chloride, so this is our reactant, and that's our reactant mass, was found to produce 38.05 kilograms of sodium, and that's our sodium mass. Calculate, so that's our product mass. However, we'll come back to that in a second. Calculate the maximum possible mass of sodium that could be produced, and use this figure to calculate the percentage yield of this reaction. So that's a yield of sodium made in the real world. The question's actually asking us how much could you make in a perfect world. So if we use the same equation that we saw previously, so our product mass is equal to our reactant mass times our product MR times by our product moles, all divided by our reactant MR times by our reactant moles. So if we take the information from the question and replace all these things with the relevant numbers, so the reactant mass is 120 kilograms because sodium chloride is the reactant, and that's the mass there, so it's 120. Our product MR, okay, is the MR of sodium, or the AR of sodium, and that's given to us here, okay, so that's 23. Our product moles we take from the equation. Now, we could consider this to be a one-to-one reaction, but we'll put the numbers in as shown in the question. So that's at 2. And then we will divide that by the reactant MR. Okay, so the reactant is sodium chloride, and its MR is 23 plus 35.5, which is 58.5. And then our reactant moles, again, we could use a one-to-one, but as we've started down the road of using a 2, continue down that road, so that's also 2. So the reason we could have used 1, of course, is because these actually cancel each other out. So 2 divided by 2 is 1, so they cancel each other out. So effectively, the calculation we're doing is this one here. And this one gives us an answer of 47.1 kilograms. Okay, and then the second part of this question asks you then to consider what the actual yield is, because in the real world, they only actually make 38.05 kilograms of sodium, okay, because there will be losses due to various reasons. And so the yield is that 38.05. That's what's actually made, divided by 47.1. Times 100%. Okay, and we'll find that that's in the region of 81%. Okay, so that's that then.
In this video, we're going to talk about the basics of moles. We're going to learn about what they are, and we're going to talk about some of these important numbers and terms. Now, we're going to start from the very beginning on moles here. So